The project I'm building in today's video features an Arduino, the most famous microcontroller, and no electronics project is actually an electronics project without a microcontroller. And we're using the famous and tested Arduino, mine looks like it has tentacles jumping out of it, but these are jumper wires or jumper cables. I'm preparing for the project I'm about to build, so I just needed to get the cables in the right slots. And so we have an Arduino, the most obvious. We have an ultrasonic sensor, HC-R something. I don't know what it is, but it's gonna be on the screen. And this right here, this little bad boy, it measures distance. And we have a potentiometer. I have to remove this. It fell. We have a potentiometer that just fell. I guess it is scared of the screen, and we have a lot of jumper cables, obviously. Jumper wires. I call them cables, but jumper wires. We have a breadboard. We're gonna need a breadboard for this project. Obviously, you can decide to, solder everything together, but honestly, I am not that experienced. I'm here to learn. And lastly, we have an LCD, 16:2 LCD board or monitor. I don't know, but yeah, we're gonna be using this, and we're gonna be building something with all of these components, especially the potentiometer that just fell. Wait, let me grab it. And yeah, I'll try to make this video as educational as possible. I'll try to make it as entertaining, share what I'm learning, what I've learned through. I'll share the resources that I've also used and that I'm going to be using in the video. And I hope it is, I hope you like it. I hope you enjoy it. I hope you learn something from it. And that's it for me for the intro. And let's get into it. I will quickly take you through the connections we're going to use to build our ultrasonic sensor project. And we're going to be using a 16:2 LCD display and a potentiometer to control the contrast. And obviously we have the Arduino board, and we have the ultrasonic sensor here, right here. So the connections we're going to be using are very simple. You can think of them like two separate projects or two separate connections. They all connect to the Arduino board basically, but here we go. So the most obvious one with a lot of connections is the 16:2 LCD display. Obviously, Arduino board has input-output pins, and they're clearly labeled on your Arduino board. So look at your connections properly. You have 0 to 1, 0 to 13 on one side, and you have like on the other side, like different labels, different label pins. And obviously, look for the one with 0 to 1 and look for pin number 1 connected to the RS of your 16:2 LCD display. Your LCD display should have something like this: GND, VCC, VO, RS, RW, read write, E, D0, D1, D2, D3, 4, 5, 6, 7, anode and cathode, which stand for A and K. So you should have all these pins on your LCD display, 16:2 LCD display, if you're using the same one as me. But if you're using a different one from Arduino, maybe you have something like VDD or VSS, or VSS and VDD. Maybe they're interchanged. Just do a quick Google search, because that's what my board says. My board uses VSS and VDD. VDD is for positive power supply, so that's where your 5 volts will go, and your VSS is where your GND will go. So it's going to be like, you're going to flip it in my own case, because the brand of my board is different from the Arduino board. So again, just be very careful and read the labels properly. And the connection is basically pin number 1 of your Arduino board is connected to RS. So be careful of the connections. RS is connected to pin number 1. Pin number 2 of the Arduino board is connected to E. And we're not using D0, D1, D2, or D3. We're not going to D4 of the LCD display. D4 is connected to pin number 4. D5 is connected to pin number 5. D6 is connected to pin number 6, and D7 is connected to pin number 7, respectively. So we have those connections. You make them properly. You connect them through your breadboard, or maybe you connect them properly and you maybe have a wire that connects like together. So do what you will, do it, like connect it, and just make sure it's connected properly. And yeah, your anode is your pin labeled A is connected to the 5 volts from the Arduino. The reason I didn't draw the connection here is because I don't want to make a long mess of a line. So pin number A is connected to the 5 volt from your Arduino. Make sure the connection is in the right place, and connect your 5 volts of the Arduino to your breadboard and the anode of your LCD display to your breadboard in the correct spot. And your cathode is connected to the ground. So there are 3 pins on your LCD display that connects to the ground. You have the K, you have RW, and we have the GND, obviously. So it stands for ground. All these 3 pins, GND, RW, and K, are connected to the same ground, which is connected to less than a bit, and it's connected to the ground of your Arduino board right here. So you can see this, and you can see this connection, GND, RW, and K connected to the ground. So keep that in mind and make sure it's connected properly. The most important thing about like electronics is your connection. So make sure you have your connections right, and mostly everything is going to take care of itself from there. And yeah, and obviously your VCC in your LCD display is connected to the 5 volts from your Arduino, and just connect it on the right spot on your breadboard, or maybe you have jumper cables that are actually long enough to connect to each other, and just make sure it is right. And yeah, your potentiometer here, same thing, 5 volts is connected to the 5 volts from the Arduino. The V out of the potentiometer is connected to the VO of the LCD 16x2 LCD display. This is used to control the contrast, as you can see right here, to control how bright it is, or maybe it's bright, maybe it's not bright. Maybe it is bright enough, or maybe you want to lower the contrast a little bit. And obviously the GND is connected to the ground of the Arduino. The potentiometer has 3 pins, 5 volt, V out, and GND. So maybe yours is not labeled. The middle pin is always the V out, and you have the 5 volt and GND on both sides. Maybe you flipped it, maybe you're not sure. Just connect them and test it and see if it works. And if it's not working, the potentiometer, then you just flip the 5 volt and GND, because the middle pin is always the V out of your potentiometer. Once you have that, that's like most of the connection for our project here. The ultrasonic sensor is actually quite simple because it only has 4 pins: VCC, trig, echo, and GND. Those are just the 4 pins. So obviously the VCC is connected to the 5 volts from the Arduino. Again, connect your 5 volts of the Arduino to like your breadboard and make sure the pin of the VCC, you're using distant jumper wires, obviously. Make sure they're connected to the 5 volts of your Arduino. So VCC is connected to 5 volts from my Arduino. And your trig and echo are connected to pin number 9 and 10 respectively. So trig is connected to pin number 9 and echo is connected to pin number 10. And also your GND is connected to the ground of the Arduino. The reason why I'm using trig and echo to connect to pin number 9 and 10 is because the code I'm uploading to the Arduino is using pin number 9, trig pin number 9, echo pin number 10. That's why. And the code right here is right here. I did not write this code myself. I copied it from this article. This article right here. This is the article and I'm using the code. Dejan Nedelkovsky. So it was one that wrote it, and I didn't write it myself. So I just copied and pasted it, and I'm also using the connection you used in the article as a reference. That's why that's the same connection that I'm using. This is just to visualize it for explanation purposes and educational purposes. And obviously I've already tested it. It works. The connection works if you do it properly. And basically this is the code. If you copy and paste it from the article, which will be in the description, just copy and paste the code as long as you have connected your media connections properly. And that's the reason why I'm using trig to connect to pin number 9, echo to connect to pin number 10. And yeah, copy and paste the code. I kind of know what the code is doing. You have a setup here. You have like variables. You are declaring in your code, obviously. And yeah, and you have a loop where you're doing the digital write, digital microseconds, digital, where you're doing your calculation and stuff like that from the ultrasonic sensor. And yeah, that's it. That's how simple the project is. The major thing is just make sure your connection is right and you have a project. So right now you're gonna see the physical implementation of this connection. And yeah, it's probably going to be like, looks messy, but honestly it's not scary because you already know that your connections are right and everything looks proper. So here is the final connection and it is working. The code I used is on the display right here with the Arduino IDE right here. The distance is a simple code that I copied from this website, which I think I would have shown earlier in the video. So yeah, I just copied and pasted the video into the IDE and I uploaded it. So once I click upload, we're gonna go here. It's gonna upload the video. You see some blinking on the light, and yeah, the video is actually working. This is the ultrasonic sensor right here, Arduino board. I connected everything as I said in the video, as I said in my explanation. So yeah, this is what it is measuring right here. You can see the display says 6 centimeters and 2 inches away from. Let's zoom out a bit. This is what it is measuring, 6 centimeters and 2 inches away. You move closer, it says 3 centimeters and how many inches? 1 inch. I can't like regulate the contrast of this thing. Like obviously I can do it with my potentiometer, like I said, but to the point where you guys can see it, I don't know which point that is. Here, maybe just right here is fine. So let me zoom out again, and basically, no, you guys can see that, can you? Oh my days. So basically what I'm trying to just like show is that the distance measures, once I go far back, it shows 12 centimeter. Oh my days, this is a problem. But you can see it's working basically. Like the circuit works fine. Yeah, okay, there we go. I think this is fine. But you can't actually see me moving the object in front of the sensor. But as you can see, it is measuring fine, 18 centimeters. I'm moving it back now, 19, 20, and 8 inches. And here again, I am close to the ultrasonic sensor. Yeah, 2 inches, 1 inches. I'm going back again and forward. And actually, it was quite simple to set up because I already had my connections figured out. I already mentally mapped out everything. And this diagram I showed you earlier, it was actually very helpful for me because I actually did this myself, and it was helpful in the process of me actually connecting the board. And once you like get an idea of what the code is doing, what your connections are, it's actually very simple and pretty exciting to know that you can actually expand on this and do a lot much more. Right now, I'm limited in the space that I have to actually expand on this, but again, if you look at the code and just like kind of scan through it, it's kind of self-explanatory, especially the one I used in my video, like for this video. It has some descriptions here, and shout out to the person of this website that did this. So yeah, pretty simple to set up. Just get your jumper wires, make sure the connection is right, and you have a project on your hands that measures distance. So let me zoom out a bit and see if I can get this contrast, because the contrast is actually not showing. Oh my days, did I mess up something? No, that's a contrast, sorry. It's too bright now. Too bright? Yeah, this is like I'm trying to like figure out how to. Yep, right here, and you're measuring distance right here. Okay, there we go. Moving front and back, and yeah, basically you can. I'm not trying to like waste anybody's time, but very simple to set up. Hope you enjoyed it. Hope it has been informative. Hope you like it. Leave a like, comment, and subscribe. Thank you very much.